thought I'd jump on today and just discuss qubits a little bit, because they're getting to be a bit of a hot property now. Quantum computing is edging ever closer to our everyday existence, and as and when it comes in and makes itself a viable reality off the prototype stages and turns into something that we all get familiar with, it would be useful to know what's kind of involved, really. Now, I don't know anything about IT or quantum technology or anything like that, so I'm not putting myself forward as an expert here by any stretch of the imagination. But what I am interested in is the fact that I've read 3 totally different descriptions of what qubits are. And qubits are purportedly the little things that make quantum computers work. And they're not like standard bits in ordinary computers, they're quantum bits, hence the name, qubits. So in one description, I've heard that they are electrons spinning at double speed, effectively. So are they electrons spinning at double speed? Is that what a qubit is? Entangled particles, that's another description I've heard, that they therefore produce the entanglement effect of non-local, spooky action at a distance thing, that one. So, are they? And I've also heard it said that they're superpositioned. So if they're in superposition, they're effectively in 2 states at once. This is the Schrodinger's cat kind of principle, where an object can occupy 2 different states at the same time. In the case of the Schrodinger's cat thought experiment, it's a live cat and a dead cat that could randomly at any moment become the dead cat from the live cat. So until it's observed, it's in both states at once, and essentially that is the nature of superposition. So are qubits superpositioned? Now, I've drawn a light cone here because with light cones you get the same kind of question marks. Light cones are the modus operandum of the photon, the way in which light operates with time as the whole space-time continuum continues to take place. And you've got a past and a future line with a light cone and a present moment right intersected across the middle. Equation. So look up light cones to get more elucidation on that than I can possibly give you. And down here, I've done a précis of what appears on Feynman's diagrams, essentially. If you look at a Feynman's diagram, you'll find 2 things incoming and then a little squiggly line in the middle and then 2 things outgoing. Doesn't matter what they are, all sorts of particles can relate to Feynman's diagrams. But essentially, this is an extrapolation of that into very simple terms of what happens with a light cone and what happens therefore with the intersection of past, future and present. So you've got the future and the past represented by particles that are travelling in the forwards direction, the positive time that we experience from present to future, and then the backwards in time waves that come in the opposite direction. This is effectively the way time operates, even though we only perceive ourselves going in one direction because of entropy. Then there's the present moment, which is represented in Feynman's diagrams by the little wiggly line, whatever the particle is that is existing for that present moment in time. So I'm going to just leave it out there. Where does this fit in with qubits? Does it fit in with qubits? Do we know what they are? Have we got really the faintest idea of what it is that we're actually dealing with here? Or is it all open still to question? I'll be very interested in your thoughts and comments on this, and would love to see you when we go into the series 3 of Quantumology and look at the metaphysics behind various concepts, which may or may not, let's say that again, which may or may not relate to quantum computing. So anyway, I'll see you next time, and take care, have fun, love you loads. Bye!